Okay, ladies and gentlemen, please observe the slide. The slide shows that some application of the electronic in our house. There's electric kettle, electric socket, and also some what is that? The hair dryer. Next, as a summary, the peak current of an alternating current is the maximum current. Make sure there's the peak current. And the period of an alternating current is the time taken for one complete cycle. The frequency of an alternating current is the number of complete cycles in 1 second, where the unit is in unit of hertz. Next, an AC ammeter can be used to measure the direction current or the alternating current, and it measures RMS of the current. So from here, the RMS of effective current of an alternating current is the value of the steady current which would dissipate the same power in the given resistor. Finally, the RMS or effective value of an alternating potential difference is the value of the steady potential difference which would dissipate the same power in a given resistor. Now we observe the next slide. From here, when the AC current is connected to a resistor, so observe what is the shape of the alternating current. So the alternating current, the shape of sinusoidal show that the that is the alternating current. Once start, okay, the expression from here, V is equal to V naught sin omega t, where V is at any instant, the voltage at any instant, mana-mana saja, and the V naught is the peak voltage. Okay, V naught is the peak voltage, that means the maximum voltage, and omega is the angular frequency, where omega equal to 2 pi f. Okay, so from here, we notice that if the sinusoidal wave show that, okay, we can change the amplitude. So now let's say if the sinusoidal show that the wave represented by the oscilloscope, which scale is 2 watt per cm. One scale, 1 cm means that 2 watt. That means that this will show that it's around 2 watt because 1 cm. And the time is 0.04 second per cm. That means 1 scale, 1 cm is equal to 0.04. That means that here, how much? 1, 2, 3, 4, 5. That means that in 5 cm show the period. So that means the period is equal to 5 times 0.04. That means the period is 0.2 seconds. What happened? Okay, if the frequency increase, once I increase the frequency or increase the amplitude, initially like that, right? If increase the frequency, that means that the number of the complete oscillation here, 3 and plus, will increase. That means now increase to 1, 2, 3, 4, 5, 6. That means 6 plus, that means the frequency double. How about the amplitude double? Amplitude double, okay, later, yeah. If amplitude double, this show that the amplitude is double. That means that the amplitude become higher, or the amplitude become double if we double the alternating current. Okay, let's, okay, for a while, yeah. Computer loading again. Okay, for the Okay, let's look at the VT graph. VT graph show how to solve it. So we notice that the period, what is the period? The period of the oscillation will be equal to how much? At cm 1, 2, 3, 4, 5, 6, 7, 8. One complete oscillation. The time taken for one complete oscillation is equal to 0.02 because the scale is set to 0. Okay, so 0.02 second per cm. 0.02, and voltage will be 1 watt per cm. Yeah, so that means that the period of the oscillation is equal to at times 0.06, that's 0.16. The frequency f equal to 1 over t, that's in 1 over 0.16. We get that it will be 6.25 hertz. And what is the peak value of the voltage? Peak value maximum. That means here 1 cm, 2 cm, 3 cm. The scale set is 1 watt per cm, right? So that means it will be 3 watt. And what is the expression for V in terms of T? At any expression, okay, any expression, that means that it will be 3. This is the sin graph. So that means that 3 sin 2 pi f t. That means 2 sin omega t. So 2 sin omega t, that means that at the, 3 sin omega t. Okay, 3 sin times with omega, that is 2 pi f angular frequency, 2 pi f t. So at the end, we get it 3 sin 12.5 pi t. Ladies and gentlemen, next slide shows that when the alternating current flow through a resistor, we notice that the voltage, the potential difference, the alternating potential difference across the resistor and the current, they are in the same phase. That means if the voltage increase, alternating voltage increase, alternating current also increase. So once the current reduce, voltage also reduce. This shows that they are in phase. Okay, they are in the same phase. Now we look at the, how about if I combine the VT graph and the IT graph together, voltage and the current in the same graph. We notice that red color will be the current, V will be the blue color. Blue color and red color always in the same phase, just the magnitude difference. Okay, but the time taken to complete one oscillation are equal. They are in the same frequency, but they are in different amplitude. Again, they reach the equilibrium at the same time. As a summary, we can say that a sinusoidal potential difference can be represented by V equal to V naught sin omega t. A sinusoidal AC current can be represented by I equal to I naught sin omega t, where the potential difference across the resistor and the current are in phase. Both of them are in the same phase. Ladies and gentlemen, please observe the slide. The current and the potential difference and the current which flow through a resistor by using alternating current, they are in the same phase. Okay, so what we can do is, how about the power? This is the, let's say this is the V, this is the I. That means that power P is equal to IV, correct or not? P is equal to IV means, well, if we want to find the power, if we wish to find out the power, that means that we use the formula of P. We use the formula P equal to IV. That means that now will be current times with the voltage. So if current times with voltage at 0, 0 will be 0. Maximum I, maximum V, that means that it will become higher. Okay, that means that the power will become more higher because it is the product of IV. So that means V sin V not sin omega t times with I not sin omega t. That means it will be V not I not sin square omega t. Okay, it will be sin. It will be I not V not sin square omega t. Ladies and gentlemen, please observe that how is the power? The power would be like that. You see, I positive, V positive, positive. I negative, V negative, it becomes positive. So the graph for a power always show that it's a positive. Next, how about the PT graph? PT graph, P equal to I naught, V naught. Okay, then what is the shaded area? Once we shed the area, that means this show that this is the IV. But we notice that, okay, so that means that now 1/2 half of the peak. What is means half of the peak? That means that this is, okay, this is the maximum can be achieved. Okay, but not all. But this one, 1/2 peak, that means that we can set that this is average power. Okay, which is stable. Okay, where in all time, it will be achieved around 1/2 pp. Okay, that means that this will be the power in the alternating current, and this will be the maximum. Okay, can be achieved, but not all time remain. Okay, so that's why we use the 1/2 pp. So now we look at the definition. Okay, average of the rectangle is equal to 1/2 pp. Average of the rectangle. Okay, times with t. So we get that 1/2 I naught V naught times with P. Hence, the energy dissipated. Okay, PT. E equal to PT. So 1/2 I naught V naught times with T will be the energy dissipated. Energy convert to heat or convert to others energy. So average energy, we use the energy dissipated in one circle. 1/2 I naught V naught T. So we use the confirm, the average power. So that means that at the end we get that 1/2 I naught V naught or 1/2 I2 square, or we get that 1/2 V naught square over R. Okay, so that means that the power become half. Okay, this come from the formula. This come from the formula of which formula? This come from the P equal to IV. P equal to I2R and P equal to V square over R. This is in stable. Okay, in general. Okay, if this is DC, general, if we use the DC, we use this formula, direct current, which we learned in Form 5, right? If we use AC, P will be equal to half of IV, I naught, V naught, okay, half. So that means that the P will be equal to half of the I naught square times with R. And for the AC, P will be equal to half again, because it's half of the peak power. Okay, that means V naught square over R. where in general we said that the P in AC, yeah, P in AC is equal to half of the P naught. Okay, P naught means that is the peak voltage, maximum power. Maximum power can be achieved, but actually reality stable just half only, half of the peak voltage. We observe the next slide. Derivation of RMS value for sinusoidal AC. So average power is equal to 1/2 I naught square R. If the steady current that produce the same power in the resistor is IRMS, then I square RMS R equal to 1/2 I square I naught square R. Hence, IRMS is equal to I naught over square root of 2. Since V is equal to IR, that means that VRMS over R is equal to 1 over square root of 2 V naught over R. As a result, we can say that VRMS is equal to V naught over square root divided by square root of 2. VRMS, that means that is the stable voltage. Stable voltage where the V naught is equal to peak voltage over square root of 2. This concept actually is equal to the just now what we have the V. What we learned just now, okay, same thing, the concept is like that. If this is the alternating voltage, where is V? So that means that this will be V naught. How about the V peak? Okay, V peak, that means that when it's in the stable, okay, let's say it's like that. When it's in the stable, that means that this one we divide, move in. Okay, so it will always show that the stable is VRMS. Okay, VRMS value. So that means that will be the constant voltage or guaranteed voltage that produce, okay, convert to others, okay, energy, either heat or others energy state. Okay, now what is the value of the shaded area? The value of the shaded area is equal to 1/2 pp. Okay, so this one just now, okay, so we just apply the formula. So energy, okay, energy dissipated in one cycle is equal to 1/2 I naught V naught T over the T. So at the end we get that 1/2 I naught V naught. Since 1/2 I naught times with I naught I2R, since 1/2 I2R, right? So that means that V equal to, where V equal to IR, we substitute in, we get that 1/2 I naught R. So that means that the average power can also be half of the V naught square over R. So that means that the how to get the, okay, the power. The power, okay, same thing. Here divide by 2. So fill in, so we get that the power. Ladies and gentlemen, how is the work example? When a sinusoidal voltage of peak value V naught is applied to a circuit which containing a diode, the variation of the output voltage V with the same time, with the time t, is as shown. What is the RMS value of V in terms of V naught? Now we notice that. Observe the power graph of one cycle. One cycle, the peak voltage is V naught square over R. So the stable power will be 1/2 V naught square over R. Okay, so 1/2 area in one cycle is found be first changing it to the rectangle. the energy dissipated in one circle is 1 over 2 V naught square over R times with T over 2 half. So at the end, we get that it will be 1 over 4 V naught square over R times T. And finally, the energy dissipated in complete cycle will be equal to average power times with T. So that means that the power, average power, is 1 over 4 V naught square over R. As a result, we can set that 1 over 4 actually is VRMS. The VRMS is equal to V naught over square. Okay, that means it's from the circuit. As a result, we can set that the average power dissipated by a resistor in an AC circuit is P equal to 1 over 2 V naught I naught, where the power voltage and the current labeled in electrical appliance are their RMS value, the power. So for a sinusoidal AC, IRMS, the formula equal to I naught over square root of 2. And VRMS will be equal to V naught over square root of 2. Here come to the end of the lesson. So Sam, ladies and gentlemen, later I will post the question on our Telegram group. So students, please solve the question before you check the answer. Here will be the question for number 1, question number 1, question number 2, question number 3, question number 4, question number 5, question number 6, question number 7, question number 8, question number 9, question number 10, 11, 12, and question number 13. That's all for today. Thank you very much and see you on next lesson. Okay.